Hello children, now we are going to see about a very interesting law in physics which is called as Newton's law of gravitation. It is otherwise called as Newton's universal law of gravitation. Okay children, now the statement goes like this, right? I will first say the statement, then I will explain it with the equation. All the bodies in the universe attracts every other body with a force, right? That force is directly proportional to the product of the masses and inversely means denominator, proportional to the square of the distance between the bodies. For example, I am one of the object in the universe, right children? Now this is another object. Now we have this duster and my body, me, will possess some force. How much that force will be? It will be equal to it is directly proportional to the product of body 1 and product of body, mass of body 2. Product of mass of body 1 and mass of body 2. And inversely proportional to, there will be some distance, no. That distance square to that factor, the force will be inversely proportional. Can you get this point children? So now that is mathematically explained as F is directly proportional to M1, M2, mass of the two bodies. Here we have taken only two bodies, that's why we are going with M1, M2. If there are so many bodies, we can multiply all the masses and square of the distance between the two bodies, right? Now that is what I have diagrammatically explained here. Two bodies I have taken, M1, M2, and it is separated by the distance R. Here the center of the masses are connected. Here the distance must be calculated from the center of the masses, right? So now here proportional to product of the masses and inversely proportional to the square of the distance. You know that to remove the proportionality, you should add one constant. Here the constant is named as capital G, right? So proportionality is replaced by equal to symbol and a constant. And all the other terms will be replaced as it is. Here this G is called as, underline children, universal gravitational constant. Before we had learnt one G, that is small g, that will change from for planet to planet. But this G, it is a universally, it is a gravitational constant, it will not change. Okay, so that its value is experimentally determined, that you will learn in your higher classes how to determine its value. G is equal to 6.674 into 10 power minus 11. And we are getting the unit. I'll explain you how we are getting this unit. Newton meter square per kilogram square. So underline this, very important value. You will learn this till you have physics in your higher classes. So what is the value of G, capital G? 6.674 into 10 power minus 11 Newton meter square per kilogram square. How we are getting this unit? Now from this formula, we will get the formula for G. So G is equal to, this R square will come over here as numerator and M1, M2 will come down as denominator. So G is equal to F R square M1, M2. So from this, what is unit of F? Newton. What is unit of radius? This is R square. Radius unit is meter. So R square is meter square. So meter square. M1, M2. M1 is kilogram, M2 is kilogram. So kilogram into kilogram, kilogram square, but that is in denominator. So when it moves to the numerator, it will go with minus. So kilogram power minus 2. So that is why we are getting the unit of G to be Newton meter square per kilogram square. So remember, no need to mug up these values, children, and units here. As you learn more and more time, it will automatically recorded in your mind. But learn it more and more time. So unit also, no need to get highly tensed how to remember this unit. Know the formula, basic formula. From this basic formula, get the formula for this. From the formula, you can derive the units. Yes, once or twice you will derive, and as you do, the units will get automatically stored in your brain. Right? So that is how we get this. Right? Now at the end of your lesson, some applications of this law is given. That I am going to teach you now itself. Okay? Right. First one, based on this law, dimensions, first point is dimensions of heavenly bodies. Whatever it is, star, planet, comet, whatever the heavenly bodies may be, its dimension like mass, size and radius, all these factors can be determined. Now you take this. If F is known, R is known, mass can be determined from this equation. If F is known, G is a constant, already we know. F is known, R is known, M2 is known, M1 can be determined. So like this, if a few quantity is known, with another unknown quantity can be determined. That is what is the first point. Second one, discovering new stars and planets. For example, right? Suddenly one planet is discovered, means how they are discovering it. Now the scientists will watch all the astronomical bodies, right? Now if there is sudden change in these factors, right? For example, if a star is nearing the earth, right? So a star is nearing the earth means some effect change will be there in the force acting between the between the earth and the neighboring planet, between which the star is coming. So when there is a change in the force, automatically what they will understand? There is some factors getting changed in these terms. Then they will get into the research. So this is how they will discover new planets and stars. Right. Now next one. Stars will have a type of movement called wobble movement. When that wobble means it has a sudden irregularity will happen in the star's movement, right? So when that happens like this, the surrounding neighboring astronomical bodies to that star will get affected. Due to the change in the force over there, the mass of that particular star can be determined based on this equation. Okay, children? Next one. This is excellent application of this Newton's law, children. It's used in agriculture. See, Newton's law is used in agriculture. Germination of roots. You know very well now, children, root will show positive geotropism. It will go down the earth, right? So how much they will germinate? They can, based on these factors, gravitational force, mass, and the radius. Based on these factors, they will research and they will find out how much a root can germinate, and that details will help the agriculturists, right? Then a prediction of the path of the astronomical bodies. So if analyzing these concepts, when any body is moving, its path, in which direction, in which way it will move. So that also the scientist can analyze using this equation. They'll substitute all the values and they'll determine this R. That R will give you the path of the planet. So though it may appears very simple, children, as a theoretical concept to you, the research involved in this is a very elaborate one, okay, which as you go high in higher classes, you will understand it in an elaborate way. So it is a very important law, children. Note it down. Take down the question. State and explain Newton's universal law of gravitation. Right. G, capital G, under quotation. G is called as dash. and its value is dash. As I asked value, don't forget to give the units. Value must accompany with unit. Right. This formula you note it down, children. Right. Otherwise you can have this as fill in the blanks. The formula for finding capital G is dash. Next question. Very important question. Give the applications of Newton's universal law of gravitation. Thank you, children.